Welcome back to the channel. Watch the video until the end, leave a like, and subscribe to the channel to support us. The issue is not if all this will happen, but rather when.
This catchy phrase, often used in cinema, aims to focus our attention not so much on the probability of an event or its truthfulness, but on our preparedness for its inevitable occurrence. The transhumanist debate on the possibility of achieving immortality seems to be structured exactly on these lines. The issue does not seem to be if it will be possible, but rather how, when, and with what consequences. The so-called transhumanism is a school of thought that aims to guide humanity towards a post-human condition, using advanced technology to overcome the biological limits of the human being, and with them, therefore, diseases, aging, and, why not, even death. But how can one even think of conquering death, the only certainty of the living? Yet, as science-fictional as it may seem to us, this possibility seems to find agreement among scientists and experts from various disciplines, at least to the extent that no one seems to vehemently support that all this is unthinkable. Currently, the average life expectancy of a human is 73 years, with significant variations between different geographical areas. Only 65 years in Africa, 73 in Russia, and as high as 81 in Europe.
Italy, with its 84 years, is ranked between the 2nd and the 8th place in the world, depending on the sources.
The United Nations Department of Social Affairs, based on recently observed trends, estimates that by 2100 human life expectancy will increase by 5 to 10 years compared to today. However, various factors could change the situation and overturn this prediction. For example, there are scenarios in which the average life expectancy could drastically decrease, rather than increase, due to various looming threats, such as global warming and resource depletion. In the opposite direction, the most convinced transhumanists predict an imminent surge in human lifespan thanks to one or more significant scientific advancements. This article will be developed in 2 episodes, proposing a classification into 3 categories of possible applications of science to the transhumanist cause. The genetic biological approach, which aims to understand and intervene in the aging process. The technological approach, which envisages the use of advanced nanotechnologies to treat diseases or create artificial organs. And the post-humanist approach, which pushes reflection very far, hypothesizing scenarios in which human consciousness is completely transferred to forms of existence different from the current ones. Every year, about 60 million human beings die. Of these, more than half are over 70 years old, an age beyond which most diseases acquire an irreversible dimension, thus becoming a cause of death. Reflecting on the aging process, it emerges that to stop or reverse it, it would be necessary to find a way to restore the length of telomeres or prevent their shortening. This could allow overcoming the Hayflick limit, ensuring that cells continue to replicate and renew tissues for an indefinite duration. The solution to this problem already exists, in part, in our organism and is represented by telomerase, a crucial enzyme in preserving telomeres during cell division. However, in an adult human, the activity of this enzyme is limited and tends to decrease with age. A famous experiment conducted by researchers at Harvard University in 2010 showed that activating telomerase in mice significantly improved cardiac and muscular function, increasing the lifespan of the animals. These results are promising and indicate that, at least in theory, stimulating the production of telomerase could allow a kind of rejuvenation. Despite the evident potential, the reactivation of telomerase in humans still raises many questions, particularly regarding possible side effects, including an increased risk of developing tumors. In fact, cancer is characterized by the ability of some cells to become immortal precisely by reactivating telomerase, allowing them to proliferate without limits. In addition to attempts to restore the length of telomeres, there are other promising research avenues to combat aging and related diseases. One of these is the use of stem cells, particularly induced pluripotent stem cells, iPSCs, discovered by Japanese biologist Shinya Yamanaka. These cells, obtained by reprogramming adult cells, can differentiate into any type of cell in the body, offering enormous possibilities for regenerative medicine and the fight against aging. In conclusion, the debate on immortality and the extension of human life is complex and multifaceted, embracing scientific, ethical, and philosophical issues.
Even if the idea of becoming immortal remains for now more a philosophical concept than an immediate prospect, scientific advances are opening previously unimaginable scenarios.
These research efforts, although still in their infancy, suggest that significant extension of human life could become a reality in the not-too-distant future, bringing with it important reflections on the very meaning of life, health, and human experience.